Unlocking the secrets, master the art of SQL injection and unleash the power of data manipulation. Hello everyone, this is Asim from Skills Build Training, and this channel is all about how to make you an IT pro really fast. Today we are going to talk about SQL injection in ethical hacking for beginners. SQL injections have been around for years and they have been a result of some of the most common serious data breaches in history. Why? Because databases are at the heart of web applications and they are filled with vulnerable data. SQL injections are still prevalent. In fact, an Akami report tracking the top web attack vectors from November 2017 to March 2019 found that SQL injections represent nearly 2/3 of all web application attacks. In this video, we start out by learning what SQLmap is. Then we move on to creating a home lab environment so that we can use SQLmap against vulnerable environments and find our first SQL injection. We'll also take a look at some of the most common and most useful features SQLmap has to offer to the beginners. So let's get started. Before we jump in and learn how to use SQLmap, we need to have a good understanding of what it is and what it is not. SQLmap is an automatic SQL injection and database takeover tool. It's an open source tool, meaning that you can view its entire code base, and this code base is maintained by a group of contributors, including the original authors. You can contribute to the project and you could even create your own version of it if you want to. SQLmap is designed as a penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. Once SQL injection flaws are found, this tool can help you exploit the vulnerabilities to the maximum extent by using a large number of different features. In some cases, SQLmap can help you completely take over database servers. In terms of SQL injections, this really is a powerful tool. It includes features like database fingerprinting, which gathers information about what database engine and version, etc. an application is using, which is really useful for reconnaissance. Then full support for major database engines like MySQL, Oracle, Postgre, SQL Server, and a bunch of others. Full support for 6 SQL injection techniques, which includes Boolean-based blind, time-based blind, error-based, union query-based, tag queries, and out-of-band. It also provides support to enumerate users, password hashes, privileges, roles, databases, tables, and columns. Enumeration gathers additional information from database in order to and then exploit it and hopefully reveal all the information I just mentioned before. It also provides support to download and upload files and execute arbitrary commands on the database server. It provides support to establish out-of-band connections between an attacker machine and the database server, which is a more advanced technique that makes connections from the database server to your own remote server in order to retrieve results or execute different commands. While it sounds like a magical tool, and to some degree it is a pretty magical tool, but it is not a silver bullet. For one, while it automates a lot, it still requires human interaction and human skill to point it in the right direction and to properly configure it. Just like any other tool, it has its limitations. So while it's a great tool to have in your arsenal, and any web pen tester should absolutely learn how to use it, it's not a silver bullet, meaning that you can't just run this tool, find nothing, and then call it a day. That won't guarantee that there are not any SQL injections. It will just help speed up the process and potentially find vulnerabilities that you don't have manually found. It can also be a tool that you add to your automated workflow when deploying new code, which again can help augment your team and help as part of our DevOps pipeline. Now there are many questions which might come across your mind after learning about SQLmap. Some of the most common questions which you can ask that is SQLmap illegal? Short answer is no. SQLmap is perfectly legal. Then another question which you can ask, can SQLmap be traced? This answer also depends on what you mean by traced and also what configurations you use for SQL map. But if we go with the typical meaning of traced in cybersecurity, meaning that someone could find you out who used SQL map against their platform, then with default SQL map configuration, yes, you are traceable. However, there are other options you can use to mask your traces, such as using a Tor setting that tunnels your traffic through Tor, which means you are just as untraceable as any other user of Tor. Now we will walk through setting up the environment for SQL injection testing. The first thing we need to configure is Kali Linux, which is a free Linux distribution that is often used for digital forensics and penetration testing. The reason we want to use Kali is because it comes up with pre-installed tools that we will be using throughout the video tutorial, and it will help us get going and avoid issues that can come from running different operating systems. You need to download the VMware from its website and install it. Then you need to create a virtual environment and install Kali. For that, you can download the Kali from official Kali website. After installation, you can set up your Kali. For a detailed information about Kali Linux and its features, you can watch my previous video. I'll share the links in the description. Now we all are set up for the Kali environment, so let's install Docker. For that, open the terminal and run the command sudo apt update, which is required to update the Linux system. And then install the Docker by the command sudo apt install docker.io. At this point, the Docker service is started but not enabled. You can reboot the system to automatically enable the Docker. If that is not the case, you need to run this command sudo systemctl enable docker now. Now the last step is to enter our non-root user to the Docker group. Sudo usermod ag docker user. We now need to reload settings so that its permission change applies. The best way to reload permissions is to log out and log back in. If you don't want to do that, make a new terminal Docker environment. Run the command new group docker. Now our Docker is ready to pull in different environments as we need. If we want to run the damn vulnerable web application, we can do that with this simple command docker run and then 8p port 8080 then vulnerables web twi. You will have to wait until it downloads the needed images and start the container. After that, it will show you the Apache access logs, so you can see requests going through the web server. It will take a couple of minutes to download all the dependencies and install the container image. Now you can navigate to 127.0.0.1 in your browser. In order to access the web application, it will ask you to log in, and you can use the username admin and password. Initially, you will be redirected to localhost page where you can check configurations and then create the database. It should automatically redirect you to log in again. But if it doesn't, scroll down and click on login to re-log in. Do manually shut down the environment. Go back to the terminal window where we started the container and use Ctrl+C or CMD+C to get our terminal back and terminate the Docker environment. Now that we have got our lab environment up and running, it's time to open the SQL map. By default, SQL map comes pre-installed with Kali Linux. So as long as you followed the steps in the prior lesson and download the latest Kali image, then you should have a very up-to-date SQL map installation. You can open the SQL map in Kali using terminal window, or you can open by this tool and then choose SQL map. As you can see the version number, you can check the latest release on GitHub repository also. In case of version difference, we can clone the Git repository using this command git clone and this. For this, you need to have Git installed in your system. I hope now you have the latest SQL map installed in your Kali system. Use SQL map-h in terminal window to open a brief commands which you can use with this tool. Let's start by looking over the introduction section of the tools documentation on GitHub. On this page, they give us a very simple example of what a target URL might look like for SQL injection. We have a target IP, a path to an endpoint, and a query parameter of ID 1. To check for SQL injection, we might alter the parameter value from being 1 to being something different, like 1 plus and plus 1 or 1 plus and plus 1 equals 2, and watching for the result on the web page or via the HTTP request. By passing in the same target to SQL map, the tool will identify the parameters to test, which is ID. Then identify which SQL injection technique can be used to try and exploit the parameter. Then fingerprint the backend database management system to gather information about what technologies we are dealing with. And depending on what it finds, it attempts to exploit vulnerabilities. Well, we can head over to the usage section of this documentation, which includes a massive comprehensive list of all SQL map options and how to use them. Now shifting back to our terminal and scrolling to the top, we can see a list of options for target. As we saw the prior example, we want to able to tell SQL map which target to go after, and we can use the very first option of -u or URL in order to specify that. Then we use a section for request, which lets us specify how we want SQL map to connect to our target URL. This is important to understand because different requests and targets require different approaches. If it's a GET request, that is different than if it is a POST request. If it is a POST request, we'll need to pass in -data equals all caps data, where all caps data is a string to be sent through the POST request. We may also need to pass in cookie, where all caps cookie is an HTTP cookie header value, because if we are going after an application that requires authentication and the authentication uses cookies, then our SQL map request won't go through and will get rejected by the application unless we provide that cookie information. Another important set of options to know about is under the enumeration category. These options basically tell SQL map what to do and what to return if it finds a vulnerability that it can exploit, or if it finds information that is not properly concealed. For example, you can ask it to retrieve the current database management system user with current user. You can ask for a list of database table with tables, the entire database schema with schema, and much more. Take a quick look at the wizard option that is provided by SQL map. This option is really only useful when you are first getting started with SQL map, because once you have more experience, you can work faster and issue more powerful commands without using the wizard. But this option basically spoon feeds you what it needs to properly attack a target. Now that we have taken a look at the main available options to get us started in using SQL map, let's move on to the next phase, where we will apply what we just learned in order to issue our first SQL map command and find as well as exploit our first SQL injection with SQL map. Turn on your target environment by running docker command to pull in the environment. Then log into the app with admin as a username and password as a password. Create the database and relog in. Now that our environment is on, let's navigate to our target endpoint by going to SQL injection. At this point, you can see that we have a user input field asking for a user ID. If we type in a random number and click on submit, you'll notice the URL changes. And this gives us a hint that it's probably a GET request, which we can confirm by opening up DevTools. You can press F12 on your keyboard and going to the network tab. Then resubmit a similar request. We can see that it is indeed a GET request. And when we click on it, we'll get additional information about this request. Let's leave this open for now and let's open up another terminal and use SQL map from there. As we know, we need to pass in a target URL with the U option. So let's copy the entire URL from our browser into the terminal. Let's paste the URL including the parameter and let's paste it in our terminal in between codes just like this. So now let's submit this request even though it won't work. Now press Ctrl C to get out of this prompt. In the case of this application, it's really easy because it just uses two simple cookies. Going back to our browser and DevTools, we can see exactly what those cookies are by clicking on the Cookies tab. Then we'll find PHP session ID and we find that security is low. So it will look different than mine. Okay, so don't copy my PHP ID or it won't work. Since we need to pass in cookie information to SQLmap, let's add that to our command also. So we'll add cookie as PHP session ID equals that ID which appears on your browser, and yes, this should work now. But let's add one more option to this command, which is tables. This enumeration option will use a SQLmap a specific task to do. In this case, tables will make SQLmap enumeration database management system, meaning it will crawl the database structure and information to find and return the names of all of the tables contained in this database. Of course, that is assuming it finds a SQL injection vulnerability first, since that is going to be the entry point that allows us to do that. So our final command will be SQLmap and then this target and then cookies and then addition of tables. Now press enter and sit back. With how we entered this command, SQLmap will periodically stop and prompt us to make a decision. Here it is saying that backend database management system is MySQL. So it's asking if it wants us to skip test payloads specific to our database, which makes sense. If we know it's MySQL, there is no point in using unrelated payloads. So we'll say why. And by the way, you will notice the default because it is capitalized. Again, it asks us another question. Do we want to include all tests for MySQL? Let's say yes. As SQLmap is running, let's take a look at our terminal that is running the container. You'll notice requests coming through from SQLmap. These are the requests being sent by SQLmap to the server, or in this case, local container. So you can see the exact payloads being submitted. But once again, it asks us a question. Let's answer no, since it says the parameter ID is vulnerable, so there is no need for us to keep testing other parameters. Now scrolling back up to where we answered no, we can see additional information about injection points, successful payloads, and then information returned from SQLmap will look like the database management system, which is MySQL, then database name, which is DBWA information schema, then the tables in those databases is guest book and users. So this information is returned, specifically asked for database tables to be enumerated. So SQLmap did exactly as we asked. It attacked our target endpoint, found a SQL injection vulnerability via the ID parameter, exploited that vulnerability, and then enumerated the database's tables. Let's also enumerate the database schema instead of tables, just to switch it up. So adding the batch is what going to automatically use default behavior instead of asking for user input. This gives us a ton of information that will help us write a report back to our client about the vulnerability which we have found, and the information, disclosure, and other potential exploitations. We can also enumerate the user's table. We need to enumerate that table in order to see if we can grab those passwords, which will very likely be stored in an encrypted format, which we should try and crack. We can do this by narrowing down SQLmap's focus to enumerate columns in just this table with the -t table option, where table represents the database table or tables to enumerate. We'll change this command with columns and T, then users batch. Now press enter. And we'll be able to confirm that there is a password column in this table. So now we are going to use the dump option in order to dump the data contained in the user's table. We will write this command and press enter. While this is working, we can see that it asked us if we want to store hashes to a temporary file for further processing with other tools. Well, this is a practical feature and we are not going to need that here. So the default was N, which means that it didn't save them. Next, it also asked if we want to crack the hashes via dictionary based attack, and the default was Y, which means that SQLmap then launches a dictionary based attack against the hashes found in the database. We can see here that by default it uses this directory, but we could have specified a custom directory file or even a file with a list of dictionary files. The final option that it asks is whether we want to use common password suffixes, which is slower. So by default it says no. Then we can see that it started the attack, and shortly after it was able to crack multiple password hashes. So now we end up with a neatly formatted table that contains the user ID, user, avatar, password, which include the hash and cracked password and other columns in this table. So SQLmap not only enumerated the table and found password, but it also has a built-in cracker that was able to crack these password hashes and give us the plain text version of the password. So this was a demonstration of SQL injections, but do not try it illegally or you will end up in jail. For more such tech-savvy content, follow this channel and I'll see you in the next video.